Hello everybody, I will start my today another coding practice. So in this video, I will solve this question. Range some query 2D. Yep. I don't know how many times I've solved this question in my life, but I decided to take this video today again. Yep. Okay, so in this question, I'm giving a 2D matrix, and I will handle multiple queries of the following types. Number one, updates the value in a cell, value of a cell in matrix. Okay. Number one is update query. Number two, calculates the sum of the element of matrix inside the rectangle, defined by its upper left corner and lower right corner. Okay, so in the second query, I will calculate the sum. So I can say this is the sum query. And the argument I will be giving is row 1, column 1, and row 2, column 2. And the rectangle is defined by these two cells. Yep. And my task is to implement the num-matrix class. Yep. In the initializer, yep. Yeah, I'm given the matrix. So yeah, okay. The matrix is already filled in. And in the update method, yeah, this is the update query. So updates the value of matrix row column to be var. Okay. And in the third one, sum region query, I return the sum of the element in the matrix. Yep. Okay. Good. So yeah, let me clarify the question statement first. So I initialize the matrix, and matrix can not be empty because of this constraint. Mn is larger than 1 but smaller than 200. Yep. M and N are number of rows and numbers columns. Okay. And aside from that, yep. I'm curious if in the update query, row and column specified is always exists in the range. I mean, in the matrix. And I will check it in the constraint. So in update method, yep, row column here is in the range of the matrix. So yep, I could confirm that in the update query, row and column specified is always inside of the matrix. Okay, and the third one, sum region query. I'm interested. I mean, I'm concerned about the same thing, but it says like this. So I can say, yeah, row 1, column 1, and row 2, column 2 are in the matrix. And also I can find from here that row 1, row 2, column 1, column 2 relations, it is possible that the column first cell and the second cell are the same cell, but it's okay. In that case, it represents the one cell only. But also I can say the second cell, row 2, column 2, is always on the right bottom of row 1, column 1. Yeah. Okay, great. So I can confirm the input of this question. So let me think of this question with some examples. Yep. So for example, this one, I'm given the num matrix with this. Yep. And then I get the sum region to 2, 1 and 4, 3, which signifies 2, 1 here and 4, 3 here. So I get the sum of this red rectangle and return it. Yep. Which should be 8. Yes. Then after that, I get the update query with 322. So this one, the cell 0 is updated with 2. And after that, the sum region query is called with the same argument. So yep, I return the sum of the same rectangle, but the number 0 in the rectangle is updated with 2, so the sum should be 10, which is 8 plus 2, which makes sense. Okay, great. So let me think. So in this question, I will introduce some solutions based on the some, situations. So number one, update heavy version. Number two, some region heavy version. And number three, balanced version. Yeah. Okay, so yeah. In the update heavy version, I mean, I'd like to finish the update query as early as possible. Yeah, because it codes so heavily. But I accept the sum region query to take some time. Yeah. So I should say I will optimize update query, sacrificing the sum region query performance. And for sum region heavy version, number two, is the opposite. And the balanced version, um, yeah, I optimize both of them in a good balance. So I will implement these three versions. Okay, let me go with this. Yeah, I will do sum region heavy version first, and then update heavy version next. Oh, sorry. Let me change my mind. I will do it in this order. Sorry. Okay, so I will do the number one, update heavy version. So obviously, this is quite simple. If the update heavy version, I'd like to finish sum region very quickly. So what I can do is in the update query, just finish with updating the cell, which takes a constant time. And in the sum region, I will do some calculation. In the worst case, I will take a look at every cell, in the rectangle. Oh, no, yeah, I will take a look at every cell in the rectangle. So in the worst case, it takes n squared time. But I'm pretty sure this I can optimize this. So let me think. So yeah. So the way I can, um, speed up the, you know, some region query is by holding the, you know, kind of cache. So I'd like to avoid calculating each of the cell. So let me think how I can optimize it. Hmm. So what I'm thinking is for each cell, I will take care of the, you know, um, tab rectangle. I mean, the rectangle, which is like this. So in this case, the cell with value 4 is responsible for caching the result of 1, 2, 3, 4. Right top right rectangle. Yeah. The sum of this should be 10. Yeah. So I will memorize the values of the sum. I mean the sum in each cell. Yeah. And in that way, I can speed up the update query. Yeah. So what I mean by that is, say if I try to get the sum of 4559 rectangle, in that case, I will take a look at this and I will think of the sum of the 1, 2, 3, 3, 4, 5, 3, 5, 9, 3 by 3 rectangle sum. So let me say. Sum which ends with D. Yeah. So in this case, if I try to get the sum from A to D, it should be sum of D minus sum of B y minus sum of z plus sum of x. Yep. This is because when I think of this 2 by 2 cell, I first recalculate the sum of this and reduce the sum of this. Then I reduce the sum of, the rectangle from of 4 by 3, which is finishes with 3. But if I do that, I mean reduce rectangle x twice, so I increment. Yeah, I add it. Yeah, so this is a kind of formula I can use to calculate sum A to D in the constant time. Yeah, and to use this, I try to cache, yeah, the sum until each cell from the top left cell. But when I think of the update method, oh, I mean, in the update heavy version, I'd like to update this in the, say, linear time or n-log time instead. So, yeah. I don't know if this is possible or not. I think, okay, so let me introduce that way later. So I'm pretty sure if I'd like to optimize the, some region method, the update method is degraded, and the time component becomes worse than O1. So I will work on it later. So now I will implement this one. Okay, so and for some region, yeah, this is it. Okay, in the update method, I just update the cell, and in some region, I will take a look at each row column in the rectangle and I mean, each cell in the rectangle and updates the returned sum, which is eventually returned. Okay, let's submit my code. Oh, accepted. Okay, so this is the update heavy version. The key is that. Oh, sorry. Update method is takes only the constant time, which is super fast. And for some region, it takes all of squared time, which is, you know, um, yeah, compromised. Okay. Now I will implement the second method. Some region heavy version. Okay, if the sum region is heavy, I can use this method. So basically, I use my time to update the cache. Yep. And with that, for some region method, it takes only the constant time. So let me implement it. So if I update the, some cell, every cell which includes this should be updated. So like if I update this 4, every cell which is includes this 4, sorry, every rectangle which update includes this 4, I mean the cache of them should be updated. So this affects the caches of the cell 4 and 5 and 5 and 9. In the worst case, if I update the cell 1, which is at the top left, I have to update the cache of every cell, so it takes n squared time. But the good thing is that some region takes only the constant time. That's the key. Okay, that being said, let me implement this. So basically, I can do it in this way. So yeah, for each row, I create the copy of that row, and that should be the row in the sum cache to the matrix. Maybe matrix dot copy can do that work, but I'm not pretty sure this does the deep copy. Yeah. So just in case, I used row dot copy with which is a copy. I mean deep copy of the one the array. Okay, so this is how I get some cache. Now I will take a look at update method. Okay, so for update method, let's think this 4 is updated to 5. In that case, it is incremented by 1. So the sum until this cell in the top right rectangle should be updated by, incremented by 1, and same for this cell, and this cell. So that's what I will do from now. Okay. So I get number of rows and number of columns. Yep. So I add this div to each cell in the sum cache. Okay, this is it. And one thing I forgot to do is I also have to update the original matrix, self.matrix, like this. Okay, so this is it. Mm. And with this idea, you know, self.cache sum cache is always up to date. So when I think of the sum region, I can use this, formula. Let me implement it. Okay, then I guess the sum cache of this, and what I will do is decrement this and this, some y and some z. But I have to take care for, say, some y. If, sorry, yeah, if this A, which is the top right cell, no, top left cell, is the row number 1, which is the, you know, first row, in that case, I don't have to do it because I can't take this, upper rectangle. So I just have to take care of it when I do this. So if this row is second row or later, yep, I will decrement it. Okay, and same for some x. Like this. Then in the end, I increment this, but also this can be the same because, if this x is in the first row or first column, I can take it. Yep, I will also take care of it. Okay, in this way. Good. Then I return the rate. Yeah, so this is it. Okay, so let me execute my code with this. Mm. Some region is wrong. Let me see. So oh, this one. Press equal div. Mm. So what I can see from this is the first sum region returns 2, which is wrong. Oh wait, yeah. One thing I forgot to do is for some cache, I didn't calculate it. I have to calculate it obviously. Yeah, let me do that. So to calculate the sum cache, yep. One thing I can do is in the brute force way, I will take a look at each cell as the right bottom, and I calculate the rectangle on the top left side one by one, but it takes n cubed time. So what I can optimize this is I use the result of the previous, or upward or leftward, you know, rectangle sum. Yep. Mm. Or I should say, wait a minute. Mm. Okay, so let me do that. So I initiate the sum cache to the matrix, and what I can do is okay. So I was like, yeah. What I can do is I will use exactly like this. Or maybe I can use this update method inside of this initializer. Mm, because yeah, I think so. Let me use it inside of this initializer. So initiate with only 0. So I assume that all of the cells are 0 now. And what I will do is update each cell one by one. But wait, if I do that, the time complexity should be n squared by times n squared. It takes so much time. So to calculate the sum cache, for example, if I try to calculate this d, yeah. Okay, so what I will do is, wait a minute. So when I think of this d, okay, so I will fill in this cell in this order: first row, second row, third row, fourth row. So if I initiate this b, if I try to update this b, um, you know, XYA calculation is already done, so I can use that result. So I can do sum until B cell B is this sum plus this sum minus this sum. So let me use that. So what I will do is I will take a look at each cell. Let me do this. No. Then if row and column, each of them is equal to one or larger, I have to decrease this. Okay, so let me try it again. Oh. Okay, it's almost there, but one thing I found is even though I added 2, it's now 10 decremented. So maybe this is because of this is the problem of update. Oh, so this is it. To get the diff, I have to subtract. Yep, new value minus. I mean, I have to think of new value minus old value obviously. Good, and I submit. Risk assignment index out of range. So, I see. This is opposite. Okay. Hmm? Object type int has no length. Wait, what's happening here? Wait. Here, I don't know why, but it's updated in the wrong way. Good. Okay, now it's accepted. So this is the summary registration heavy version. So the important thing is some region query code is finished in the constant time, even though for the update it takes n squared time. Okay, so now I will think of the balanced version. Okay, so in this, my goal is to finish update less than n squared time and also some region less than n squared time. Yep, in a at the same time. Yeah. Okay. And the approach I can use for this case is that in the second approach, I mean update heavy version, um, I use the 2D region, but in this case, I use a bit different version of the caching, which is I will keep track of the cache only of the row in each row. So I will cache 1, 1 plus 2, 1 plus 2 plus 3 in this row. And similarly, I will cache 4 plus 6 and 4 plus 6 plus 9. Then in the last one, I will cache only 8 plus 1 plus 3. Yeah. Once I cache this, for example, if I'd like to think of the sum until this one, I will take a look at this cache 1 plus 2, 4 plus 6, and 8 plus 1, and calculate the total sum of these three caches. So in this way, the sum region query, it takes only O of wait, O of m number of rows. And for pace, no, sorry, I was talking about sum region. And for update query, this takes O of column, number of columns. Because if I'd like to say, if I update number 4 in the second row, I have to update the cache in this row. Yeah. So it should be, yeah. Say for replace with 5 in this case, I update the cache in the way like 5, 5 plus 6, 5 plus 6 plus 9. So it takes number of columns times. Okay. So obviously this is updated. Yeah, it's an update query or sorry, the first version or second version. So what I've noticed is that the matrix is not always, square. So I update the, time complexity n squared with m by n. Okay. And m is number of rows and c is number of columns. So yeah, this is it. Okay, so I will implement this. So in the update method, no, in the initializer, I do almost a similar thing as sum region. Sorry, the second version is implementation, but only difference is that cache takes care of only that row. Okay, so number of rows and number of columns is like this. Yep. So here, I initialize only the first column in each row. Then from the second column in that row, I will do it in this for loop. In this way. Okay. So now I finished the implementation of the initializer. Now I will update the update query. So here, what I will do is update the original matrix, number one, and number two, I will update the cache. And for the cache, I mean, I have to update the cache in the same row as the specified cell and column which is equal or greater than the specified column. So if I specify this one, I have to update the cache of this and this. Okay. So I will do that. So this is a def. Yeah. Yep. So this is how I update the cache. Yep. So for each column from the specified column, I will update the sum. Good. Now I think of the sum region. As I said, in this method, if I try to guess the sum of the DS5, I will add the cache of this and this and this, which means the cache of the same column with every row until that specified row. So I will do that. Oh wait, no, I'm saying something wrong. So if I try to guess the sum until sum of say 4559, what I have to get is the sum until this and then sum until this and no. What I try to guess the sum of this. Yep. What I would do is for each row in the rectangle included in the rectangle, I guess the cache until this 5 minus cache until 3. Cache until 9 minus cache until 3 in this row. And then I just get the total of them. So in sum region method, for each row between row 1 and row 2, Yeah, I get the row sum, which should be like this. However, well, I have to take care of the case when wait, row column 2 minus row column 1 minus 1. Yep, I have to take care of the case when column 1 is equal to 0. In that case, I don't have to subtract any row cache. Oh, okay, so let me rename this sum cache with row cache. Yep, so I will take care of it. The row sum is this, and if column 1 is larger than 1, I decrease this. Okay, so this is the row sum. So I added this row sum to the returned value. Okay, and I return it. Good. Okay, let me execute my code. Oh, typo. Good. I submit my code. Okay. Okay, wrong answer. So in this case, update, and some region failed. -3 or -4. Okay. Maybe I'd like to, oh wait, one thing I forgot to do is in update method, I forgot to update the matrix. I will do that. Okay. Let me try this test case again. Looks good. I submit again. Okay, accepted. So this is the balanced version. So the key is that update query and some region query is optimized in a balanced way. The good thing is if I compare this with some region version, some region heavy version, obviously some region method takes more time than that version, but update version takes less time than that version. Yeah. And I can say the same when I compare this balanced version with some regions heavy version or update version. Yep. Good. So yeah, one thing I can add is that for balanced version, there is a better solution which I use segment tree. Yep. So with segment tree or maybe with binary index tree, from here I can see that I can do it in log mn. Same for some region. Yep. But let me, yeah. Yeah, skip that implementation because it's super hard because I have to use the 2D segment tree or something like that. So in this video, I just, showed the cache, row cache solution. And obviously, if number of rows is quite so many, much more than number of columns, and say if I'd like to, you know, prioritize update performance, maybe I can use the column cache instead of the row cache. So it depends. Yeah. Okay, so that being said, I will quickly wrap up my today's coding practice. So in this video, I solved the question, range some query to the mutable. Yeah. And in this question, I'm giving the matrix and then there are two queries which are run on this matrix. Number one, update query. So specific cell value is updated with the specified value. And number two, sum query. So I'm given two cells and I have to return the sum of the rectangle, which has, you know, left top left cell and bottom left cell, sorry, bottom right cell with specified cells. Yeah. So that's the second query. And in this video, I introduced three implementations. So for the first one, I was for the update heavy version. Yeah. And in that implementation, I didn't use any cache. So for update query, I just update, or I should say mutate the query, the matrix of the given one. And then in sum region query, I take a look at each cell in the rectangle and return the total sum of it. Yeah, and in the sum region heavy version, I use the cache, a kind of 2D cache. Yep. So every time update is run, I completely update the to the cache so that update query can be finished in the constant time complexity. Yep. And in the balanced version, I use the 1D cache. So I use the prefix sum cache in each row. Yeah, as a matrix, as a cache matrix. And with that, to update the cache in update query, it takes a constant time. So it takes the linear time. And some region takes also the linear time by making use of the cache I prepared. Okay, so that being said, I finished my today's coding practice. Thank you so much. Bye.